This section will show a strategy specifically designed for solving word problems. So many students see a word problem and mentally shut down because they perceive it to be much more difficult. However, if you follow the steps of the KUDOS method, you will take the words out of the word problem and turn it into a simple calculation problem. KUDOS stands for known, unknown, definition, output, substantiation. Step K, known. Identify what is known. Use units to identify information. Grams gives mass. Write information symbolically so that it's easier to read. Instead of in sentence form, write it symbolically. M equals 2.67 grams. Look for implied information. If one percentage is given, the other can be implied. Write out chemical reactions. Rather than reading them in sentence form, write them symbolically. The second step, U, is to identify the unknown. Look for words like how many or what to identify the question. For example, how many milliliters? The problem is looking for milliliters, which is a volume unit. Write information symbolically. For example, transform how many milliliters into volume equals unknown milliliters. Identifying the unknown early in the process helps you focus and work more efficiently. The third step is the most critical. D. Define the needed information. Search for needed equalities. For example, to convert to milliliters, the milliliter equality is necessary. Choose and rearrange equations. When working on a density problem, first choose the correct equation and then rearrange it to solve for the unknown variable. If you can't find enough information, try looking in other places, such as the periodic table. If you still can't find enough information, try re-evaluating your approach. Maybe there's a better way to attack the problem. The fourth step is step O, output. Find the output for your information. Plug values into equations. This is where your known information and your definition information are used together. Use fundamental constants if necessary. Check unit cancellation to make sure all the units do cancel and leave you with the correct unit. And then finally, perform the actual calculation to give you your answer. The last step, S, is to substantiate your answer. Check to make sure it's valid, that it's in the ballpark, and that it's physically possible. Check validity. Is it reasonable? Is it 10,000 when it should be around 10? Check units. Are the units left after cancellation appropriate for what you were solving for? Check significant figures. Are the significant figures in the answer correct? When multiplying or dividing, use the least number of significant figures in the problem. When adding or subtracting, use the least number of decimal places in the problem. The definition step connects the known and the unknown. This is often one of the hardest things for students to do. This is why the definition step is so critical. Watch an example of the KUDOS method using Dalton's law of partial pressure. Step K. Identify the known. This problem has two pieces of known information. Step U. Identify the unknown. Step D. Define by writing the law of partial pressure and solving for the unknown variable. Step O. Use your equation to solve for the unknown variable. Step S. Check your answer. 1.53 is reasonable as it is less than the total pressure in the system. ATM is the correct pressure unit. 2 decimal places was given in the problem, and because it's subtraction, 2 decimal places is needed in the answer. The KUDOS method can be used to work stoichiometry problems that are given in word form. Step K. Identify the known information. Step U. Identify the unknown. Step D. Definitions, such as chemical equations. Step O. Use the ratio to convert from molecules of the known, oxygen, to molecules of the unknown, water. Your given information is written on the left side of the workspace. The desired unit is written on the right side. The ratio is used so that molecules of oxygen will cancel. Therefore, oxygen needs to be placed on the bottom. Substantiate your answer. 1.58 times 10 to the 29th molecules is reasonable considering the given information. Molecules of water is what is being asked for in the problem. With multiplication and division, count significant figures. 3 were given, 3 are in the answer. This example shows how units may need to be converted before being used in an equation. Step K. Identify the known information. The volume is given in liters. The density is given in grams per milliliter. Step U. Identify the unknown information. The mass. Step D. First, the units of volume will need to be converted so that they will cancel out later on. The correct equivalent is 1 milliliter equals 0.001 liter. The density equation is then rearranged to solve for the unknown variable. In the output step, the units are first converted by writing the known unit on the far left side of the workspace. The unknown is written on the right side. The ratio is arranged so that the known unit cancels to give you the desired unit. This new volume can be used in the density equation to solve for mass. Finally, check your answer. 321 grams is reasonable for 125 milliliters with a density of about 2.5. Grams is the valid unit for mass. 3 significant figures were given in both given informations, and 3 significant figures appear in the answer. The general 5-step problem-solving strategy can be used on any type of problem. For word problems, use the KUDOS, which is just a specific example of the general problem-solving strategy adapted to word problems.